Okay, the next type of problem is a mixture problem. And usually the examples that you're going to see, they're going to be talking about making metal alloys or different liquid mixtures, maybe perhaps baking or cooking, things like that, where they add different things together to come up with a new product. So this one that I'm looking at, it says a metal alloy is a metal made by blending two or more types of metals. So they're putting two different metals together to create a new one. A jeweler has supplies of two metal alloys. One alloy is 30% gold and the other is 10% gold. How much of each alloy should the jeweler combine to create 4 kilograms of an alloy containing 15% gold? So he's mixing two different types of golds to come up with a new one, maybe to make a ring or a necklace or whatever the case may be. So here are my notes that I'm going to write so you can follow with what I'm doing. One of the metals that he has is made 30% gold. He has another one that's 10% gold. So he's going to melt these down and mix them together. So the first question is how much of each should he make to create 4 kilograms? Well, first of all, you're putting two things together, and when you put two things together, you are adding. So I'm going to call this one X, and this one's going to be my Y. Well, no matter what I have of X, I know that when I add it to my Y, I'm going to have a total of 4 kilograms. I'm not going to put the kg up there because I don't want the k and the g to throw you off as a variable. But when I add these two together, I know that I want a total amount of 4 kilograms. So when I add my x and my y, I want a total of 4. There's my first one. Now, here is the slightly trickier part. Remember that you're going to melt these down and mix them together. So you need to know how, what's the density. So the first one is 30% gold. We don't really like to multiply or work with percents, but it's very easy to change percents to decimals. And I hope you remember, but to change a percent to a decimal, I hope you're saying this out loud. When you change a percent to a decimal, all you do with the decimal is move it 2 places to the left. So if I move this 2 places to the left, it's the same thing as 0.3. So that would be 0.3 of x, because I still don't know how much of x I'm going to add, but I do know that 0.3 of it, 30% of it, is gold. So that means that when I change this one to a decimal so I can multiply, it would be 0.1. And remember, that was y. Okay, so I know that I'm adding these together. I've changed my percents to decimals. Here's the part where you need to know. When you add those together, in the problem, it said that it wanted an alloy of 15% gold. And 15% gold would be 0.15. And I'm going to rewrite this underneath because I really want you to see this. So we have 0.3x plus 0.1y is equal, they want 15%, which is 0.15, of whatever amount you want. Well, the amount that he's making is 4, so that would be 0.15 of 4, or times 4. So that's how I would write it. Now if you look, you have two equations. Here's number 1, x plus, when you add them together, x plus y equals 4, that's the total they want. And here's number 2, this is where they're getting specific with the gold content. If you look, this first one would be pretty simple to solve for one of the variables. Now, if you can jump ahead and see this, multiplying a number by 0.1 isn't too bad. So I think this one would be easier to substitute for. You can substitute either, it'll work out the same, but I'm going to pick that one. So I'm going to solve this equation for y, which means that I'm going to subtract x on both sides. So what I get is y is equal to 4 minus x. Then I'm going to substitute. So what I get is 0.3x plus 0.1 times 4 minus x is equal to, I'm going to jump ahead, 0.15 times 4 is 0.6. All I did was simplify this part right here. Okay, then I need to distribute. So I get 0.3x plus 0.1 times 4. Well, 1 times 4 is 4. You've got that decimal in there, so that's 0.4 minus distribute 0.1x is equal to 0.6. Now I'm going to combine like terms, my 0.3x minus my 0.1, which is 0.2x, plus 0.4 is equal to 0.6. Subtract 0.4 on both sides. I'm going to write that over here, so I get 0.2x is equal to 0.2. Hopefully you're able to follow that with me. And then if you divide 0.2 by 0.2, okay, I solved for my y. I got 1. So once I get this, I can plug this in up on this one. Well, 1 plus what number equals 4? This one's easy enough. You can do it in your head. So you know that y is equal to, well, 1 plus 3 equals 4. So you know that y is equal to 3. So I'm going to write this down here and put a box around it so you can see it. Just plug it in and check and see if that works on the other one. I'm going to grab a different color here because this is looking pretty crazy. Okay, so if you plug in your numbers over here, if you plug in 1, well, 0.3 times 1 is 0.3, and 0.1 times, what's y, 3? It's 0.3. So I should have done it right here, sorry, because you can't see the rest of that problem because I ran out of room. Okay, so if I plug in 1 here and 1 here, I get 0.3 plus 0.3, this is a 3, sorry, and 0.15 times 4 was equal to 0.6. Well, 0.3 plus 0.3 is equal to 0.6. So it works in both of them, so you know that your answer is correct. So remember that the question was how much of each alloy should the jeweler combine to create 4 kilograms of an alloy containing 15% gold. Well, remember, X was 1 and X was 3, and you were working in kilograms. So you would need 1 kilogram of the first alloy and 3 kilograms of the second alloy. Really sorry about that mess. Wish I was there so I could use the whole board to write this out, but hopefully once you look at this one and you follow the example in the book, it won't be complete gibberish for you. And finally, looking at problems involving rates. The example in your book uses what they call tailwinds. And tailwinds is when the wind is at your back. So with the wind, it helps you go a little bit faster. And if you've ever gone for a run outside, you know that if you have the wind at your back, it kind of helps you and it makes you run a little bit faster. Or if you're running against the wind, it slows you down, even though you feel like you're working, just as hard or harder. So tailwinds is when the wind is at your back. So there's 2 things that you need to think about. Whatever speed you're going, speed is a rate. Whatever your speed is, and they call it airspeed, if the wind is at your back, you're going to add the wind speed because it's going to make you faster. So you would take the airspeed plus the wind speed, and that's going to give you what they call ground speed. Well, if you go in the opposite direction and the wind is in your face or against you, it's going to slow you down. So that would be your airspeed minus the wind speed because you're going to have to overcome that wind in your face. So it's going to slow you down. So you would subtract. So again, with the tailwind, that's going to add to your speed. But when you go against the tailwind or in the opposite direction, you're going to have to take that off your speed because it's going to slow you down. Hopefully that makes sense. Okay, so our problem that we're going to solve, it says, with a tailwind, a bird flew at a ground speed of 3 miles per hour. So overall, with the wind, he was traveling at 3 miles per hour. We don't know what the airspeed was. We don't know what the wind speed was, but we know that overall, taking all of it into consideration, he was going 3 miles per hour. Then, on its return, so when the bird turned around and flew back to the nest or wherever it was going, the bird was traveling at a ground speed of 1.5 miles per hour. Knowing this, we can figure out what the wind speed was in either direction. Okay? This would be an example of a problem that you would want to use elimination, because if you would add these two equations together, and I'm going to rewrite this, so you have your airspeed plus your wind speed equals 3, and your airspeed minus your wind speed equals 1.5. If you notice this, you have two coefficients that would easily cancel each other out. In front of that variable would be a 1, so you have a positive 1 and a negative 1. So I am going to write these vertically. So I have a plus 1 equals 3, a plus w equals 3, a minus w equals 1.5, and all you have to do is add these two equations together, and you're going to eliminate your wind speed. You're going to find your airspeed. So these would cancel. So you get a plus a is 2a is equal to 4.5. Well, isolate your variable, divide by 2. So your airspeed is 2.25. Simply plug in what you know, which is a, and solve for your missing variable. So if I plug a is equal to 2.25 into this equation, I get 2.25 plus your wind speed is equal to 3. Well, if you subtract 2.25, sorry, I'm going to run out of room on both sides, pretend like you can see it all, you get w is equal to 0.75. So here I have my a, and here I have my w. Plug that into your other one and see if it works. So a is 2.25 minus 0.75, and if my math is correct, 2.25 minus 0.75 is equal to 1.5, so this would be true. So the question is, what was the bird's airspeed? Well, the bird's airspeed, right here, a, is 2.25 miles per hour, and the wind speed that day would have been 0.75 miles per hour. All right, trust me, I know that these are not the easiest problems to start working with. Just like always, I hope you guys are beginning to believe me that the more you try these, the easier they get. I would highly, highly encourage you to work with a partner on these, bounce ideas off each other, see if you can figure out what to use for the variable, which method to use, and see if you can make it work. I know that you're going to sit back and say, I'm never going to do this, but there are a lot of people that do problems like this quite frequently. Good luck, and I will see you guys a week from this coming Monday.